Welcome to Group Problems 11. I am here with Camille Douse and I'm Katie Jones, and this is Group K. So 1A. This question concerns the molecules involved in translation. So indicate the group of enzymes that covalently link amino acids to tRNA molecules, and that's amino acyl tRNA synthetases. 1B. Indicate 4 proteins that consume GTP during translation, and that's IF3, IF2, IF1, and EFG. 1C. Indicate one molecule that functions as a ribozyme during translation, and that's peptidyl transferase. 1D. Indicate 2 proteins that recognize stop codons, and that's RF1 and RF2. And 1A. Indicate one molecule that forms hydrogen bonds with the Shine-Dalgarno sequence in the mRNA, and that's IF3.
Alright, so for 2, it's a fill in the blank. For A, it's the first amino acid in prokaryotic proteins is FMET. B, an E. coli protein called blank delivers charged tRNAs to the A site of the ribosome during translation elongation, and that's the EF2. C, the initiator tRNA binds to the blank site of the ribosome, whereas the remaining charged tRNAs bind to the blank site of the ribosome, and it's the P and then the A sites. For 2D, it's blank is a translation factor that helps the ribosome move one codon in the 3' direction along the mRNA, and that is the EFG. For E, it's blank is a translation factor that guides the mRNA to the 30S ribosome subunit, and that is the Shine-Dalgarno sequence. For F, it's the blank codon is the start codon, while blank is an example of a stop codon. And it's the AUG and then the UAA, and both of those are 5' to 3'. For G, it's blank is a term that indicates that more than one codon can specify the same amino acid and is synonymous. H, the final amino acid is located at the blank terminus of the polypeptide, and it is the A.
Alright, 3. The series of mRNA codons are indicated below. Consider the wobble rules and provide all possible tRNA anticodon sequences that can form hydrogen bonds with each mRNA codon. So for 3A, we have 5' UUG 3'. And so AAC and AAU are anticodons. So for 3B, 5' AGU and 3' to 3'. So we have UCG and UCA. For C, we have 5' UAC to 3', and the only one is AUG, which is the start codon. 3D, 5' AUU and 3', and its anticodons are UAA and UAG. 3E, 5' GCA to 3', we have CGU, CGC, and CGG.
So for 4, suppose that E. coli contains a protein called protein X, which is 218 kilodaltons in molecular weight. For A, so if the average amino acid is 125 daltons, how many amino acids are found in protein X? And so the 125 daltons for the protein X, the 218 kilodaltons is equal to 218,000 daltons, but there ends up being 1,024 amino acids. So for B, what is the length of the mRNA coding region, i.e. the portion of the mRNA that encodes the amino acids that are responsible for producing protein X? And so basically you take the number of amino acids multiplied by 3 because that's the amount of nucleotides in it, but so there will end up being 3,072. So for C, how many GTP molecules are consumed to synthesize each copy of protein X? And it's for each codon, there's 2 GTPs for it, and so you multiply it by 2 and it's 6,147. For D, how many ATP molecules are consumed to synthesize each copy of protein X? And it is 1 per amino acid, and so is 1,024. So for E, what is the name of the group of enzymes that consumes ATP to assist in the synthesis of protein X? And it is amino-acyl tRNA synthetases.
So 5. Below is a list of proteins and nucleic acid sequences involved in translation, and so we see this list here. So let's begin. So 5A. Which of the above is involved in translation initiation? And that's the Shine-Dalgarno 5' AUG 3', which is the start codon, IF3, IF2, tRNA FMET, 23S RNA, and 16S RNA. Which of the above is involved in the translation elongation? And that's EFG, EFTU, 23 srRNA, and 16 srRNA. 5C. Which of the above is involved in translation termination? And that's RF1 and 5' UGA 3'. 5D. Which of the above is a component of the 70S ribosome? And that's the 16 srRNA and the 34 srRNA. 5E. Which of the above is found within the mRNA? And that's 5' AUG 3' and 5' UGA 3'. And that is all. Thank you for joining us.